In the previous video, we saw the notation for a geometric series. Now we're going to see the summation and the convergence of the geometric series. So we have a sub 1 plus a sub 1 r plus a sub 2 plus a sub 1 r squared all the way to a sub 1 r to the n minus 1. And remember, we saw in the previous video that this can be expressed as the summation from k equals 0 to n minus 1. We saw that this number is going to be the same number as the exponent of the r in the last term, or 1 minus the number of terms that we have, that is n minus 1 of a sub 1 r to the k. The other way to express this is the summation from k equals 1 to 1 more than the power of the last term of the r. So that would be n minus 1 plus 1 is just n, or you think it as just k equals 1 to n, that is to the number of terms that we have. So here we have n terms because we are ending up with r to the n minus 1. Alright, now what happens if we multiply this times r? So we would have a1 times r would be a1 r. I will put it here. This times r would be a1 squared r. Then this times r would be a1 times q r, all the way down until the previous term to this, that is a1 r to the n minus 2. When I multiply this times r, here I will have a1 r to the n minus 1. And when I multiply this times r, the last term will be a1 r to the n minus 1 plus 1, just r to the n. So all the terms are matching except the first and last term. Now this is the summation from the first n terms, and this is r times the summation of the first r of the first n terms. Now let's subtract this from this. So we will have s sub n minus r s sub n equals to a sub 1, and all these are going to die. All these are going to get cancelled except this a1 r sub n actually is minus a1 r sub n because I'm subtracting. So this we can put this as s sub n times 1 minus r equals a sub 1 times 1 minus r to the n power. So s sub n is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. This is how we calculate the summation of a geometric series. The first term times 1 minus the ratio to the number of terms, that is, let's say we want to calculate the summation of the first 3 numbers, so here would be a 3, divided by 1 minus the common ratio. Maybe in the next videos we will do exercises. Now the convergence of a geometric series is if the absolute value of the common ratio, that is of r, is less than 1, the series will converge. That is because if we are multiplying by, let's say, 0.5 or 0.75, whatever, each time that we are multiplying, we are going to end up with a less number, with a number that is less than the previous. But if we are multiplying by something greater or equal than 1, we are always summing or adding the first term or the sum of the terms plus something else. So it's not less than or equal, it's just less than 1. So if the absolute value of r is less than 1, then the series converges. If the absolute value of r is greater or equal than 1, the series diverge. Now, if we know that the series converge, that is, we know that the ratio, the absolute value of the ratio is less than 1. Now, what is that value at which this series is convergence? So the series, one thing is the summation, and the other thing is the series that is converging, because the summation is the summation of the first 2 terms, of the first 20 terms, etc. So it's the summation of the n first terms. The series, if the series converge, we are talking about the infinite geometric series. So if that geometric series, that is the summation of this infinite geometric sequence, is converging at a number. So actually we're talking about the summation of the infinitely terms. So s sub n when n is equal to infinity. So let's apply this rule. This would be a sub 1 times 1 minus r to the infinity divided by 1 minus r. Now r to infinity is r to infinity if the absolute value of r is less than 1. Let's say is 0.75 or 0.5, wherever we can put this as 3/4, 1/2, etc. When we elevate this 1/2 to infinity, here the denominator always grows more rapidly than the numerator. So if we take the limit at infinity, the numerator is going to be less than the denominator, and the denominator is approaching infinity faster, and so this limit, or this r to the infinity, approaches 0. That is only when the absolute value of r is less than 1. So we are just doing this because we already know that the absolute value of r is less than 1, because we are saying that the series converges, and now we want to see to what value is the series converging. So a sub 1 times 1 minus r to the infinity divided by 1 minus r. This is just a divided by 1 minus r, because this r to the infinity, being the absolute value of r less than 1, is just 0. So this is 0, 1 minus 0 is just 1, and so the series will converge to the value that is the first term divided by 1 minus the common ratio. So how do we calculate this sum? It's just the first term times 1 minus the common ratio to the n power divided by 1 minus the common ratio. If the series converges, that is, if the absolute value of r is less than 1, then the value at which the series is converging, or the summation of the infinitely terms, approaches to a divided by 1 minus the common ratio.